We're going to learn a little bit about the stack pointer and how to call functions using assembly. So first of all, what is the stack pointer? Well, the stack pointer is a location in the data SRAM that refers to another location in the data SRAM that can be used as a last in, first out data structure. Typically, the location that is set up by your program for the stack is the end of the data SRAM. The reason for that is the stack pointer is typically decremented when data is added into it and incremented when data is moved out. This way, it starts at the end and moves towards the beginning. This helps to prevent collisions between data that is written at the low address spaces and then added towards the end. So your program will have to actually set the value of the stack pointer, and we'll cover that a little in a different section. But for now, just assume that the stack pointer has been set to the end of your data SRAM. The way this is used is most commonly when calling functions. So there's a couple of things you can do. First of all, you can use the stack in your code to save registers and other values. But when you want to call a function, the stack pointer is used to remember the last location that the program counter held before the function was called, so that way when the function is done, it can return to that location. To kind of illustrate this further, we're going to walk through a simple program. At the beginning of the program counter is 0, and the microcontroller begins and executes command 1. Once command 1 is finished, program counter is incremented, and the next command is executed by the microcontroller. In this case, the assembly command call is run. Call does a couple of things. First of all, it takes the current value of the program counter and adds 1 and pops that onto the stack, pushes that onto the stack. So then, since the stack is pointing to EOF, we come down to the address EOF and we would see the value 2 entered there, because that is the program counter plus 1. Once that's done, then the stack pointer is decremented. So the stack pointer would then become EOF minus 1. Then the program counter is updated so that it references the memory location function. In this case, that address is 3. So we're skipping the command 2. Then the microcontroller continues execution and executes what's at function, increments the program counter, executes the command F1, again increments the program counter, and at this point executes the special assembly command return, RET. And this effectively does the opposite of what the call function does. So it looks out at the stack, grabs the value that's out there. First of all, it goes out to the stack, it increments the stack pointer, pushing it back to EOF, and then grabs the value that's there and pushes that into the program counter. Pops it off and changes the program counter to 2. At that point, it returns execution over to the microcontroller, and the microcontroller starts executing command 2. When it completes command 2, you'll notice that it does something a little bit unexpected, because it increments the microcontroller and now begins executing function. So in our real programs, we will need to put something in between our function and the rest of the commands so that they don't get called. This is often an error in coding, is that you'll write a function and then the microcontroller will call the function, but the function will unexpectedly be called at the end of your program because the microcontroller just continued incrementing the program counter. So that's effectively how calling a function works and how the stack and the stack pointer work.